Okay, everyone. So example 9 again, we're still trying to prove if these two triangles are similar using SAS, SSS, or AA similarity. So again, let's see what's kind of been given to us. Which if I look at my first triangle, I have a side mark congruent, I have an angle, and then I have a side mark congruent. So I have a side, then an angle, then a side. Same with this one. I have a side mark congruent, then an angle's given to me, and then I have another side given to me as congruent. So looking here, this is looking a lot like SAS similarity. And I know I'm in the clear because the angle's in between my two sides, not on the other side, which that would be SSA like in example A. We don't want to go there again. Okay, so on this one, again, we're trying to show they're not congruent, similar by SAS similarity. But in order to do that, I must show that my sides are proportionate. Which you're probably like, Miss Long, they didn't give us any side lengths. Well, I know they did not give us the side length, so it's kind of hard to figure out if these are going to be proportionate or not. So what I like to do if I'm not given any sides, I just like to make up my own. Because then I can kind of visualize it a little bit better and kind of make some conclusions from there. So like these two are marked congruent, which means they have to be the same thing. So I don't know. I'm just going to say that each of these are 4. Might as well, right? Okay, and then I know that these two are also congruent, so I don't know. I'll just make them each 2. Might as well. Okay, so now I have like made up numbers, but since I made sure that these two were the same and these two are the same, when I find my scale factors, it should be accurate as to whether or not they're proportionate. So these are definitely not necessarily what the lengths are of these sides, but they're going to help me to decide, well, are the sides proportionate or not? So let's see what happens. I don't know. Okay, so let's see here. I have, it doesn't matter which one I pick, honestly. I'm going to pick side XZ. So I'm going to say, so we're going to find our scale factor. Okay, and since they're both the same length, it doesn't really matter which one I pick. So I'm going to pick 4 over, and it doesn't really matter which one I pick over here because they're the same length. So 4 over 2, well, I can reduce this down. So 4 over 2, I can divide each of these by 2. Okay, so that will give me 4 divided by 2 is 2. 2 divided by 2 is 1. So this is going to be 2 over 1, which is 2. And again, this was given to me, so that's how I got my scale factor. Okay, so I have a side. Then the next thing I spot on my paper is an angle, which I know that angle Z is congruent to, which angle is congruent to angle Z over here? Like normally you guys are correct. So that would be angle A. And I know they're congruent because it was also given to me. So my side, my angle, and now let's see if my final sides are proportionate. Because if they are, guess what, you guys? These two triangles are going to be similar by SAS. So let's see what happens. Okay, so now I'm going to start with side ZY, which is also, I said it was 4. So we're going to find our other scale factor. Okay, so I have a 4 over the other side, which again, they're both the same, so it really doesn't matter, but that's going to be side AC, which is 2. And guys, 4 over 2 will reduce down, we already know, to 2 over 1. So guess what, you guys? Our scale factors are the same. Yes! I'm going to give it 2 thumbs up because that's exciting. Okay, and this was also given to me. So guess what, you guys? Since I was able to show that 2 sides were proportionate and the angle in between them was congruent, the 2 triangles are similar by SAS similarity. Oh man, let's go. Let's write our similarity statement now. So I'm going to say triangle XYZ is similar to triangle, let's see here, XYZ goes from 0 markings to 1 tick mark to 1 tick mark. So 0 to 1 to 1. Okay, and again, it doesn't really matter. It's kind of hard to tell which way to go because 2 of the sides are congruent. So as long as I go from 0 tick marks to 1, or 0 tick marks to 2 of the same exact sides, it doesn't really matter. So I go from 0 tick mark to 2 of the same sides. So I'm going to call this one CBA. You could also call it BCA though, because we go from 0 tick marks to 2 identical tick marks. So either way, I'm just going to call it CBA. So you could say CBA or BCA, whichever floats your boat. And these two are similar by SAS similarity. Don't forget the fancy little tilde. Okay, let's get going on example 10.